Alright. Now we should be live. So, hi everyone and thank you for tuning in. Now, what we're gonna do is, as I mentioned in my tweet, I'm gonna do some kind of live code reviewing because I think that in that open source world, especially in cybersecurity where many tools are being published, we are lacking the common sense of actually going there and debugging the code ourselves, understanding how it works, and we ended up just blindly shooting exploits, and if they fail, we are not sure why. So, to fix that, I'm gonna go over and review some Mythic agent Apple code. So Apple is the default agent. I'm not the default, my bad, but the like .NET standard agent for Mythic. First, I'm gonna go over the Mythic C2 itself, the new update that was released, Mythic 3.0. We're gonna go over the new features and then we're gonna dive into some code review. I have my shisha open ready. Let me feed up my calls real quick. We're done. And I think we should start. So if you experience any kind of like issues on both of the streams, because I'm streaming now on Twitch and on YouTube, just hit me up and we should be fine. Alright. Now let me make sure the chat is here. So if someone types something, I should get it now. So we're good to go. Alright. Now I've installed Mythic, the newest version of Mythic, and here I installed the HTTP profiles and payload types. Now what that is essentially how something communicates to us, for instance agents. So the HTTP profile means that the agent Apple or any other here would connect to us back over HTTP protocol. So Mythic supports various kind of profiles like Mythic C2 profiles. You can go over there and see like DNS, WebSockets, Slack, SMB, Dynamic HTTP, which I'm not sure what that is, but they support it. And on top of that, if you go to Mythic C2 agents, you can see all the available agents and what they support. For instance, we are going to talk about Apple. Apple is C#.NET framework based. It's actively being developed, SOC support, C2 channels, so that's what I'm talking about. The apples can connect to the specified channels, which are HTTP, TCP, and SMB. And of course, the version of operational system that it is supported on. Now, in that case, obviously, it's Windows. Yeah. With that being said, I hope you get a better idea about what agents are. Now, here, let's talk about the Mythic C2 and what's the new about that one. So, the first thing that kind of stick to my eye, and I think it's a really nice detail, is that the colors and that they use React.js now on the newest version. I'm not sure if they were using React.js on the previous one, but now they are, and you can see how much smoother the whole experience is. Now here the color is better, I think. It works nice. The dark profile is better optimized. The white profile is good as well, so we have settings for our user here. Then we have some notification of what exactly happened and when. We have some help, which is, wow, I just found it now. This is the URL, the links for the documentations about different agents and profiles. So if you get stuck, you just go there, and Mythic hosts its own documentations, so we can go there and see stuff for yourself, right? Like each command, for instance, that, which you're gonna go over later on. Now, next, give me just a second, please. All right. Alright, now it's better. I was filling up the OBS stuff. So now, let's talk about the UI. So first, this is the bar of the pretty much the things we can do. We can generate payloads from here. We can see the payloads we've generated and search for everything here, credentials, files, socks, and so on. Active callback, so we can demonstrate that in action so we can get a better idea. Now the second actually that got to my mind and I really liked it is that the build in progress stage. So for instance, when you create a payload and this payload is being developed, deployed, published, you can see the steps that is going through in order for it to get published. For instance, now if I click to download, you can see I've generated an exe file, not a shellcode. If we click to download, we can see nothing, and then the output not converting shellcode through download passing through. This is because, as I said, I used a binary instead of shellcode, and that's why it skipped download. Now, here on the second part, we can see success compilation, and here, of course, success again. So you can see what's actually going on with your paywalls and like what's the progress of their deployment. Now let's go create a new one. Let's do new Windows next. Let's do WinXZ again next. Now another thing that I like is that the default command for exit is there and you can't remove it, because in the previous versions you need to manually find it here and plug it there so the agent have exit command, but it's obvious that exit command is 100% needed because the beacon should know when to exit. Now for that case they integrated the exit command on the included command by default, and this allows us to just take it back. Now another key commands we have are upload, shell, run, ps, load and download, which are essentials for our beacon, but let's just go wild and get all the commands. Now let's do next. Let's do set up a profile. And now here's another thing I like super much about the Mythic. You can predefine your profiles. So for instance, I can include that one, and I've created one from scratch. I can do that, and you can see the values are being populated instantly. Like I have my IP being there, I have the callback port being there, and I can do, for example, let's do 2, and yeah, that's about it. So all these settings can be modified through various profiles, and you can easily switch between these profiles so easily. So that's one of the things that I super enjoy. Now let's do next, and let's call it apu2.exe. Create payload. Now here, that's why I'm talking about. Now the first step about gathering files is completed. Now it's compiling, and then of course the download should pass, but as I said, you have seen the progress of your payload right off the bat. Yeah, there it is. Now what are these details are about? I'm sure that this one was lacking from the previous Mythic instance, but what that is essentially all the configurations you have done. So for instance, you set up WinXZ to be the output, the file name, this is the URL from where you can download that, but most importantly you can check on what configurations you've applied, because in the previous version when you generate the payload you would just not was sure what config was there, and if you have like 5 payloads you cannot be sure which one of them are the correct one, especially if you're using some different IPs or VPNs and something. So that's super handy because you can just click details and see from where to where you configured your payload. For instance, now it's on port 443. Now let's close that and download it. Open up a new CMD there and do cd downloads. I can do remove. Actually, I'm gonna just host a Python server. Now let's open that SQL server there. Log in as some domain user, and let's go there and execute some commands. So I'm gonna open actually a PowerShell Windows into desktop and do IWR HTTP 192 my IP pretty much, and then apu2.exe into out file a2.exe. I'm gonna make sure that my Defender is not running because apu is heavy signatured, because you know that's an open source. What was that? Windows Defender. Yeah, there it is. Everything open source is easy to signature because you know everyone can read it, but we're not gonna be talking about evasion techniques and so on. We're just gonna ignore that for now. Run that. The file is there. Run that, and we should get a callback now. Here we have callback right off the bat. Let's open here, and this is it. So this is how we receive the callback and interact with them. Not in a lot changed here, but I like that first here we have more compact options, so we can do table layout and graph layout. Doing that, we can do a bunch of settings for this graph, like to auto size, show hidden callbacks, to change the layout to that one, to left to right instead of like the opposite. Now, another thing I pretty much like is that you can dynamically change that on the go, because for the previous patch, you need to click here and then do like a percentage of how much you want to be from top to bottom, like that on that bar here. And now you can dynamically change it as you wish, which is super nice. Now you have more space for commands. If you have more callbacks, you can do that, choose your callback, and then just bring that up again. Yeah, nice. Now here, of course, not in that much change. We can do who am I. We can go over, let's go up expand callback. And now we can do more commands here. For instance, I have config and so on. But let's move on into what new is about Mythic. And one of the things I super enjoy is that they integrated Jupyter in the common sense of forcing, or not forcing, but like making users or making people to be more script friendly and willing to learn scripting more. Because for instance, they showcased, and these snippets you see are all by default integrated with Mythic. They showcase that Mythic has its own API, and you can interact with that API via the Jupyter and to create different kind of tasks. For instance, you can use programmatic. All the jobs you see on the Mythic can be done programmatically via Python. For instance, we have a snippet to configure the Mythic callback. So the C2 profile, apologize. So these options here are the one you just saw. So you remember the name my custom C2 callback. If we go to my C2 profiles, we can do saved instances, and we can do my custom C2 callback. So there it is. Additionally, this is one of the biggest thing again. You can do it from here. So you can do save instance and you can create a new one right off the bat. But the point is that Mythic showcased, and it's a feature showcase that it's possible to interact with scripting, and they force guys and users to do it because it's super fun. And you can do quite a lot of things here. We can go with file browser, we can do kind of a lot of operations here. We can see process, we can list payloads and create new ones programmatically. So pretty much you can automate your job right off the bat with Mythic, and you don't even need to have some kind of ID. All the ID is integrated within the Mythic itself. Nice. Another thing that I'm not really familiar with is the GraphSQL. I believe that's something for getting some kind of data out and back to the Mythic server and so on, but it has its own language and kind of syntax. I didn't go into that detail into it, so I can't really say much about it. Right. But never mind, that was my quick Mythic 3 showcase. Why I'm doing that? Because I super much enjoy the framework, and I encourage you to try it because you know it works. Like, well, of course, now you can see things like that, like error container down. But even though you see a graphical UI error, the command is still there. So yeah. Now let's go over into how that thing really works and how much can you understand about this kind of beacon, because as we can see from the interaction with it, we can see that it's doing quite a, let's say, a simple job. And I've watched in podcasts, I'm not sure which one, that pretty much all of the C2s are doing like kind of the similar stuff. For instance, you need to connect a lot of machines. You need them to beacon out for a bunch of commands. So how they work is that they beacon for a command, and when you task a command, for instance, who am I, this command is tasked to a specific endpoint. When the beacon goes there and analyzes the endpoint and sees there's a command, it tries to execute it and bring you back the result. Now for that case, I'm gonna go to my command VM. I'm gonna download the Apple agent back again, and I'm gonna open Wireshark. Now what I want to do is to make sure what is visible on the network. So before we dive into code, let's actually see what is happening on the network side of things. For that case, I'm gonna do TCP, this, no, DST port, or maybe it was IP, yeah, that one. But the IP is not that, but 74, 134, yeah, that's the one, nice. Now you can see that if I just do refresh, a request gonna pop up because that's an HTTP. You can see the whole traffic. I'm gonna download the APU to, you can see all the packets of downloading the file. I'm gonna do refresh, continue, alright, and now let's just execute it. I'm gonna run it as administrator. And let's open up the Wireshark. And I'm not sure why nothing is there. Oh, my bad, because we are not receiving the traffic as an HTTP, but HTTP as one. So I need to get a bit of modification so we can see the traffic. Let's do exit on that. Now let me open up my sudo -i, type my password, cd into Mythic, cd installed services. And by the way, this is another refactor from their side. So all the things you install are in that directory, installed services. So cd installed services, I can do cd http, cd http again, cdc2 code, and then do vim config.json. Now here let's just do use SSL to be false, and then the HTTP port to be 80. Now replace that, and we need to rebuild it, or to restart it. So I can go cd into the Mythic directory and do Mythic CLI, and then do restart HTTP. Now what that's gonna do is it's gonna restart only the HTTP profile. That's another beauty, because initially I'm not a huge fan of Docker, and I pretty much hate it because the syntax is kind of bugs me out. But when I think about it, that thing is super nice, because now you can see I can restart a bunch different kind of services without affecting the others. Like, I do not need to restart the whole network, I mean the whole framework. I just need to restart what it needs to be restarted. And that's why Dockers are handy. In case you didn't know, Mythic is like heavy Dockerized. Yeah. We can see now that the HTTP is being offline. We should wait a little bit and it should pop up. Looks like to be done. And it is ready. Now here, obviously we need to generate a new payload. So let's do that and create new payload, Windows. Let's do that again, next, all the commands, next. And now use HTTP this time. Now specify my IP, leave the port as it is, and let's specify the callback for, let's say, 5 seconds, because I think with 5 seconds it's gonna be easy to debug it. So go next, make it apu http.exe, create payload. The payload is there, and by the way, the actions of me editing the HTTP config file can be now done from here. So manage files, I can go to config.json and edit it from here, which is super nice. Now the payload should be done by now. It is, but now I believe that we need to stop the server, because we can listen obviously on the same port that Mythic is, or at least I'm not sure we can. So let's try to restart the HTTP again, because I think we bugged it out with the Python HTTP server. If you guys have any questions about that, just make sure to pop them. I'm doing my best to watch all of the chats. So yeah. Or if you experience anything related to stream quality or something. All right, let's do that, grep 80, and there we are. Now it listens to port 80. All right, now we have that agent there. So now let's go over that and do, instead of 80, let's do 844 or 80, or yeah, 8443. Never mind. Now let's go back to my commando there. Open up the same URL 8443. Download the Apu HTTP and now run it as admin again. Now let's see if the first thing we have is the callback, and we have it. So we have the active callback, which is that one. Let's hide the others. So hide callback, and now let's analyze on the commando on the Wireshark. We can see the request now. Let's do follow TCP stream. A lot of data. So these are the very low level beacon requests for just pinging for commands. So what these requests are doing is that you can see these values being randomized. I'm sure that's been done on purpose, because to have some kind of entropy on the whole thing. But I believe that if you observe the payloads which are being sent, you can see that the first payload is huge, is bigger than the others. And that's because I think this is the initial payload that says to Mythic, hey, I'm connected, I'm the callback X on that machine. So this data should be, by the way, base 64 encoded. So let's try to decrypt that. Or let's do it from the terminal. Let's do it like that. Not really. It's base 64, but it's been encrypted and then base 64. So even with the, which is nice, by the way, because even with the HTTP communication, you would not be able to see what exactly is going on with this traffic, because it's initially encrypted, and that's a huge deal indeed. Now let's continue analyzing the stuff. So now, after this has been done, we can see a bunch of requests with the smaller payloads, and I believe these are for just seeing if there's a command. We have, so this is the post data, all right. Then we post to data again, all right. And then 200, okay, post data. So the data is most likely the endpoint for chaining the commands, and this data endpoint, by the way, is the one we have here. So if you go to agents, payloads, then here on the config file, you can see, yeah, post request URI, that. So make sure in real operation, just make sure to edit all these parameters, because even though they're working and the traffic is encrypted, this kind of behavior is already being signatured. So the user agent must be changed, as well as the parameters and the data. Yeah, so of course, if you go into the proxy, make sure to edit that as well. And then we have pretty much the command that this beacon have. Nice. What? I can add and remove command on the go? You're kidding me. Nice. We're gonna try that. Alright, so let's try to chain a bunch of commands. Let's go back. And yeah, we can see pretty much the same kind of behavior. We post to data, post data, post data, post data, and so on. Now let's do refresh that. And now let's issue a command. So let's go here, close, cancel that, active callback, and do who am I? The output is there, so let's do right click, follow TCP stream. Now let's analyze what's going on there, and we can see nothing fancy. So the standard behavior is before. We can try to base64 decode that. So echo dash n, paste that, base64 dash d, and we can see the same string encrypted, but that we have some kind of identifier, I believe, which I'm not sure what that's about. Never mind. So let's try to decode that as well to see if you can get anything fancy from it. So the same identifier, maybe that was the identifier of the command, I'm not really sure about that. But never mind, you can see the string, the whole communication is being encrypted, even though it is over HTTP. So it's another layer of, let's say, stealthness. Nice. So now let's just move from the network analysis, because we saw the default behavior, which is posting to data or every single callback and encrypting the commands additionally. On top of that, base64 in them. We don't need it anymore. I'm gonna quit that. Now I have already opened up some projects there, and some tests were made, but I'm gonna remove everything there, here and here as well, and I just downloaded some source codes for the Apu agent. So we have Apu 2.2.2, 2.2.1, because I was submitting some kind of issues about the agent and about the Mythic, which were resolved, and I needed to debug different kind of agents, what they were doing differently. Never mind. Now if we go to Mythic C2 Apu, we have a new version from 2.3.13 from 2 weeks ago, which is nice. Let's download the source code and analyze that. Let's copy it to desktop. Extract everything there. No to all. Alright, sorry about that. Let's do. Oh, we have a stream, alright. We have a stream. But I don't want to delete that. Alright. Where is that? Apu. Oh, come on. Alright. Wait, isn't it 2.3? Oh, maybe some kind of a. Maybe they didn't upload the releases. Yeah, it's from March 31. Yeah, which is not 2 weeks before, so they did not upload the latest release there. But never mind, it's alright. So let's analyze. I think that's not that big of a difference when it comes to the Apu versions, but now let's stick to this one. Alright, so this is here we have a bunch of code. Now, of course, this is the GitHub download. We can see the README and some documentations, and all this stuff. What we're gonna focus are insights to profiles. Not that. Sorry. Payload type, Apu, and here it is. So we have the agent code. So all this is its own solution with all the C# code where how Apu operates. Hi there. Welcome to the stream, everyone. And then we have the Mythic. Another code here. Why? Because Mythic is using where I pretty much enjoy about Mythic. It's using separation as much as possible, meaning that Mythic is separating different components to various microservices, so they can be either unplugged and replaced, or they can be easily upgraded when it's needed for. So keep in mind that when you go to Mythic and do like SSN LTP, you can see a bunch of ports being open, and majority of these ports is about Mythic. We have that one is not, but majority of the ports, they are for Mythic. Why? Is because, as I said, Mythic uses different kind of components doing kind of microservice work. For instance, this server here has its own Docker, own code, which is independent of the agent's code. You have different agents here, different C2 profiles, which as shown before, are totally like independent from one another. You can have HTTP with various agents, you can have agents on different C2 profile, and all of these microservices are connected with RPC calls. That's why we have this kind of code. We have first the Apple code, and then we have the Mythic code. So here is how I believe how the Apple agent is supposed to connect to the Mythic instance. So we can try to debug that to see how that works. So let's observe what we have here. We have agent functions. So these are all the functions we have on the Apple agent. So if you go to here and do payloads and then there, all the functions here, right here, are all the functions from here. So this is the code. Now let's observe the very primitive and basic one, which is the who am I. It's not doing anything that fancy, it just says who am I. Now the code here is not complex, let's analyze it. So first we have from Mythic payload types container, we have own Mythic library for the command base. We import everything, then we import JSON because it looks like we are parsing JSON output. Then we are doing who am I arguments. Now in that case we have some init functions, which I believe works something like constructor. Then we have parse arguments, and if it's bigger than 0, we raise an exception, takes no command line argument. So what that does is initially if you specify some command arguments to the who am I command, so if you go here and type who am I ASD, it's gonna say the same thing we saw on the code. I believe it should say that. So let's wait 5 seconds. Alright, not gonna say anything because it's parsed here. But the point is that the agent says, the code says that it does not accept arguments. Alright, since that is ready, we have the class. That is the who am I command, and as a parameter we have the command base, which I'm not sure we can just navigate by clicking there. Unknown wanna ask if I made a client in Go or Python. Let me in private OS, but I want to turn them to exe. How do I do that? I use py2exe or Nuicta, which is Python tool for converting Python code into an exe. I just replied that with the tool name. Alright. Now we have the who am I command. And all that is a class. Now this class have bunch of parameters that needs to be assigned. So in that case we have the command itself. We have the needs admin privileges. We have help command, version, author of course, the mapping type, and then two functions. The first function is gonna be create tasking, and the second one is gonna be process response. So by inheriting that, we're gonna most likely do some kind of this command based thing is most likely doing some kind of an RPC calls, and we are just defining the commands, the create tasking and the process response. So the thing you see from here by creating the task and seeing the response is based on these two lines of code. Alright, now let's shift to the C# point of view and see how the who am I command works. So let's go to agent code, open that up with the Apple solution, with Visual Studio solution, apologize. Come on. And now we are there and see how much code we have. Phew. Now all the things and commands we discussed are considered tasks. And for that tasks, by the way, This most likely the code that encrypts the payload themselves. Fuck, it looks like it. Nice. We can see we can peek into that later. Now let's focus on the whoami command, which is under tasks project. So see how good job they did by separating everything, like literally anything. This task you see is another project. Like I can do project properties. Yeah, here we have simple resolve project, screenshot inject. Like everything that can be done as a different project is done as a different project. Like phew, amazing done job. So let's go into the whoami and let's observe the code there. It's not that big, so we should take a look at it. We have a namespace tasks, which is the default namespace for the tasks project. And then we have a class whoami, which is inheriting tasking. Now let's observe what tasking is. It's an abstract class, meaning that it's not really a class you can instantiate an object and work with it, but you can think about more like an interface, something like an interface, which is, by the way, implementing an interface which is called iTask. Now this iTask is using string ID. We have, this is a function ID, we have function to start, we have a task create tasking, and then we have queue. So let's go to task. We get into a rabbit hole. Now let's go back because we don't want to be there. And let's analyze that one. So we have tasking. This implements the interface iTask. And from the interface, we have the things that have been imported. Now, here we have the data. We have the agent, which is another interface, iAgent. And this iAgent is looking like that is defined some default functions. So we have start, exit, is alive, get UID. Maybe this UID is the one we were getting from Wireshark. And we have one more functions there, which is, I believe, default for the agent itself. So no matter how much functions we do, this one's gonna be there. Now let's move back and analyze what else is going on. We have the constructor there, which specifies the data, the agent, and the constellation token, which I'm not sure what that is. Whew. Yeah, that's getting too deep. Let's move back. Now, what are we seeing now? What I wanted to see, we start with the whoami. So that inherits tasking, which is an abstract class, which have default functions for queue. So the token is used for queuing the session. We have function for getting the response from the task, which is that one. Nice, and pretty much that's it. So task is just the command that is being issued, and this tasking and iTask and all the logic behind the rabbit deep hole you saw is about how to properly initialize, work with, consist this task, and potentially queue your session or beacon. Now let's continue with the whoami. Now with the whoami we have the default ID function that we saw on the iTask. We have the implemented function for start, which you saw on the interface, and for the queue, and for the task response. Alright, it's doing that. Oh, never mind, let's go back to whoami. And let's start from here again. Now from here we have the function start. So that start to inherit from the tasking. And then here we define a response, which is, I believe, a structure, yeah. So we have a structure with 5 quotable task response and mythic messages, which I'm not sure what that is. Don't think I'm familiar with all of this code. And here, this structure defines the various fields and progress with our task. For instance, we have the output, if the task is completed, what command, and so on. So let's move back. We have the response defined from that structure, and most likely that structure is gonna get populated. So we have some if statements for get login information, which I'm not sure what exactly it's doing. Maybe if it can scan the current user's organization or token or so on. But in both of the cases, we are doing create task response. So we're querying a function, yeah, which is that one. And that function is supposed to run a command and then populate that response for us. Now here we can see that the local identity and person identity are the same strings that are being used here. So I can navigate here, go to the who am I, and there it is, local identity, impersonate identity. So if you want to modify anything with that, we can do it here, then recompile the apple, and then it's gonna be there. We can do other custom logic here, custom code, but before doing custom code, we must be super aware of all the structures what we want to populate and how to do it, because otherwise we could break the agent or the specific function. After that's been done, we do get task manager and add task response to queue, which is supposed to do to pretty much execute the task. Don't get me wrong, by executing the task, I mean that the tasks have been stored on specific endpoint, and when the agent calls back, he sees the command and then it tasks it locally. Again, for getting the response, it gets the response after again querying back. Nice. So that was the who am I. We can see a lot of logic about that, and keep in mind we have a lot of things to analyze, so I'm gonna just scratch the surface of Mythic and its code and apple. This is really the surface and see how deep this framework is. One thing that I want to showcase, which is super nice I believe, is the execute p command. So for instance, let's go there and let's try some Mimikatz. Let's do Mimikatz privilege debug. Let's wait a little bit. Observe how the output is being passed every 5 seconds. In that case, it wasn't ready until 10 seconds, so we need to wait a little bit more. And there it is. So let's observe how this command works. Now, at first we have a built-in Mimikatz command, which on the sub command, because you can see we can scroll that and zoom out, we can see it's doing another command, which Mimikatz is an alias for execute p, specify the p, mimikatz.exe, which is already registered to the Mythic server, or the agent, sorry, and then we pass the arguments like that. Now, where does this Mimikatz come from? Well, it comes from here. There it is. So by default, the Apple agent has its own Mimikatz version, and this Mimikatz version is embedded into the agent here. Now what happens is if you want to execute another portable executable, for instance, I can do execute, I need to specify the P, but there's nothing there. Why? Because I need first to register it. What happens when you register a P, a file, or a PowerShell script or something, it goes to the agent, which is here, and it downloads and then registers the file. So the agent is familiar with that specific like binary. To showcase that, let's go ahead and do a register assembly or register file, apologize, because we're not working with .NET assemblies. Let's do that, and for example, let's register ncat.exe. So open that, task that, and by running the command, imagine the ncat.exe is gonna pop up here. Now, of course, it's not gonna pop up there because I'm registering it on the Mythic server itself, on the agent itself. This is just the source code, but it's doing the same logic. So when you do register file, it drops it into the space of the agent itself, and then you can run it via execute p. Right, so let's go back, and ncat is being registered. Now I can do execute p and then run ncat. For instance, I can do any kind of port like 192, 168, 74 134 and 8443. Task that. I'm not sure why I'm not getting the output there. Maybe I messed up with the arguments. Let's try another one. Execute p nk.txt 134 8443, but let's try to call that. So do it like that. Or maybe the ncat itself is broken, not sure. No callback still. Well, I'm not sure why that is, but in a nutshell, that's how it works. So we need to dig deeper into that specifically in ncat, but I'm sure that other portable executables are way more interesting. For instance, print spoofer. So if I can do print spoofer and -h, which is again, we can see that's initial command we run. But if we zoom out, we can see it's doing the same thing. So execute p, print spoofer.exe, arguments and h. So whenever you need to execute a portable executable, you need to first write it, and there you are. We have the print spoofer up and running. Now, of course, if you need to, there's a question because I'm not sure what Mimikatz version this is using, so let's try to see that. Mimikatz 2.2.0, let's see Mimikatz, which is the newest version. Open that. It is indeed 2.2.0. Yeah, so I believe that they have updated the Mimikatz version, but if you need in some cases to use older one or specific one, you can replace it from there. So you need to just do again do sudo-i to get as root, do docker ps, now do docker exec it. So it took me time to memorize these commands, but I did it. Then go and copy the Apple container ID, paste it there, do bash for better use, and do lsla. Now cd into Apple, cd into agent code. Is this working familiar so far? And here it is. So if you need to specify and modify any kind of PE which is available, especially the Mimikatz, you can do it from here. Now again, you can also edit the print spoofer here and all the predefined code that Apple has. Alright, now let's answer some questions. Py2exe said it's like discontinued and I don't know how to use Nutka. Well, that's the point of being a pen tester. You have to learn the hard way. So nobody knows how everything works by definition. But the idea is to go there and debug it yourself. So to find blog posts, videos, anything that can be useful to suit your need. And that's how you pretty much learn in a nutshell. So let's continue back into seeing more code of the Mythic. Let's try to see PowerShell. No, not the PowerShell, but the PowerPick. So what's the difference between PowerShell and PowerPick? Because for instance, let's go there and showcase how they work. Let's do PowerShell and GCI, which is the ls command, pretty much. And we have this there. Now let's do PowerPick ls. Let's do a bit more. Or let's do PowerPick GCI because it may be, oh, there it is, there it is. So it took a while, but why? What's the difference? In a first glance, they all look the same, like they are just executing PowerShell commands, right? Well, they are, but the way they do it is quite different. So the default PowerShell command is using like PowerShell, so it's doing just that. It's starting your PowerShell process. It's getting the command, getting the output, and bringing it back. So PowerShell command is running an actual PowerShell command, while PowerPick is actually doing is injecting the PowerShell run space into another process and executes from there. So they work quite a different way, because the PowerPick is considered the stealthiest option of them all, because of course you're injecting into different process, injecting just the PowerShell run space and execute from there. Now let's observe the code difference. This is the PowerShell, and we have a lot of code, but let's try to break it down a little bit. Now, let's see how it executes command. This is the start function. We have the same task response, so it looks like all the commands are using the same kind of response structure. We have the command itself, then we are passing the commands from the arguments we have, right here, parameters command. So this parameters.command is pretty much what you type. Alright, then we try to... We are not directly executing PowerShell from the native PowerShell execution run space from C#. And why am I smoking? Well, because I enjoy smoking shisha. Yeah. Then we are adding this command, so it's using pretty much the text writer object. We have common PowerShell host. All right, we initialize the run space, create run space. All right, then we do pipeline and pass the command and execute them. This is how the built-in C# way of executing PowerShell, because you have pretty much two ways. You can start the process and then just directly run PowerShell, or you can inject and do the PowerShell run space as it is done here. The point is that it's using the run space of PowerShell from the current process. Let's now observe the PowerPick. Let's scroll to the start function, which is there, and it's a lot bigger. Now let's try to understand how it works. We have again the same task response structure. Alright, and now let's see what it does. Here, as you can see, we are creating a process. So I'm not sure what process it's picking, so let's try to see that. Get process manager, new process, and then do info arguments, info application, which I'm not sure what that is, so let's try to search for it. Oh, it's a application startup info. Alright, so we have parent process ID, application arguments. Alright, which I believe most likely is starting a sacrificial process. So what that one is doing is, I believe, it creates a new sacrificial process, gets its PID from here, alright, and then we pass that into an injection process. So we inject into that process using the PID. Then we have the same syntax for initializing the PowerShell command. Alright, we use some named pipe for that to connect to, I believe, to connect to that namespace. No, I'm talking bullshit. I think name pipe client. What's that doing? Let's do F1. I think it's native for Microsoft. Oh, it's not. Never mind. I think name pipe. So it's communicating over the process using the name pipe. At least that's what I'm thinking it's doing, because it's using the localhost for that. So it may be transferring connections from the sacrificial process. Oh yeah, I think that's about. So imagine it like that. you have your own process, and then it starts a new one. The command and the output of the command you want to run is being transferred over that async name type client, just like that. It transfers the commands in the output, and there it is. So in the first case, we transfer the command and we create a task, and then we get the response. So that's how it works in a nutshell. First, it creates a process, it injects the PowerShell run space into it, and then transfers the command and the output through the named pipe, and then just run the task. Whew. Yeah. Of course, there is not enough time to cover all the Mythic's magic and all this feature, but I think that was nice foundation on getting ahead of some like basic code review and understanding some basic functions about open source tools. With that, I'm thinking of closing the stream because it was already at least almost 1 hour since we are doing that, and I know that's not too easy to get over, especially when you're reading other people's code. You need to get into their mindset of how they did things. So I hope you enjoyed. I hope you liked the video. I'm not seeing any question, which I'm not sure if that's bad or good, but I think it's good. So thank you everyone for watching, guys. Keep in mind that this stream is going to be uploaded to YouTube, and I'm going to make a follow-up video into summarizing what we found and what we did. So appreciate everyone of you watching, and